Welcome, ladies and gentlemen, to Thursday's lesson. Today's lesson just kind of goes over an overview of bonding in general. We won't go into too much detail today, but we at least want to talk about what kind of things go into bonding. The first thing you have to talk about when we go to bonding is that the octet rule. For majority of the elements, they're trying to find a full valence electron, meaning a full shell valence electrons means they want to have 8 in their outer shell. There's only 2 exceptions, hydrogen and helium, but we won't deal with them a whole lot for right now. So you're trying to get to 8. On the flip side of that, there's some elements trying to get to 0. And when they do that, they go down a level. And since they're going down a level that's full, that's where they get there. So that's what we talk about when we talk about the octet rule. We're trying to get to 8 electrons or 0, depending on what the element is. We'll come back to ion notation. Before we do that, I got to talk about another thing real quick, and that is oxidation numbers. Oxidation numbers tell you the charge of what these elements would have when they start losing electrons. So what's going to end up happening here is you kind of look familiar. It should look familiar over here to what you've seen before. We kind of talked about having 1 valence electron, 2 valence electrons, 3, all that stuff. Well, now we're talking about charges that deal with certain ions. If you look at the left here, you have 1, 2, and 3 on the first ones. That's kind of a misnomer. It's really supposed to be positive 1, 2, and 3. We have 4 in the middle. Don't worry about that. Won't deal with that a whole lot. On the right-hand side, it says backwards a little bit, but it should be -3, -2, -1, and 0. These are important because these are going to tell you which types of things combine together in one type of bond, as well as different things as we go later on. So we need to recognize oxidation numbers for some of these elements. So use the table here to fill in this right-hand side. This right-hand side is going to be on canvas, so I'm going to at least do one of these examples for you. We want to find the oxidation number for Be. Well, if you look over here, Be is in group 2, so it's going to have an oxidation number of, let me find the thing, +2. And that's really all of it is to there. You have +2 over here. You got the negatives over here. I won't worry about 4 or 0 a whole lot. So if it's in group 2, it's a +2. Group 1, +1, so on, so forth. Don't worry about the bottom of this at all. We'll go over this on a later date. So as we take a look at here, ionic bonds. This is when 2 different types of elements combine using these charges, using those oxidation numbers that we just went over. So if we look here, you see that we have the Lewis dot structure for sodium. Well, sodium is one of those that since it has a certain amount, it's going to want to go to 0. So when we look at it, it removes that 1 electron and becomes a charge, an ion. It becomes Na +1. It says 1+, but it's +1. So if we roll back down to our oxidation number chart, that checks out because here's Na. It's in group 1. It has the oxidation number of +1. Going back up. On the flip side of this, chlorine, you notice it has 7 different electrons. So it's the easiest thing it wants to do is not give away, is to get one. So we're going to take this gain 1 electron, and it becomes a charge of -1. Now, how that kind of works, think about your little bit of English. If you have a double negative, 2 negatives equal a positive. Well, each of these electrons is a negative. So if you take in a negative, you become a negative. If you get rid of your negative, you become positive. It's kind of like when you have that bad influence in your life. Everybody's had at least one bad friend. Well, when you got rid of that one bad friend, you felt positive. That's why you got rid of it. You felt positive. If you have a negative friend in your life and you feel bad, that's what causes it to be negative. So when we look at which of these ions make compounds, we're trying to specifically talk about make ionic compounds. So they have to be of separate charges. So we look at the first one here, Mg +2 and Li +1. Well, they're both positives. They can't attract each other. So your answer here will end up being no. So if you see 2 positives on your assignment today, they do not make a chemical, or they don't make a ionic bond. They only make anything. But for like Na and O, you have a +1 -2. They're opposite charges, so they will create one. So you go ahead and put yes for that answer. So that's ionic bonds. We take the positives and the negatives and we opposites attract them together and they create ionic compounds. I will use the same ones from this oxidation chart down here to determine whether they become ionic bonds or not. So make sure you have these notes, pay attention to them as you go forward. The second type of bonding we're going to talk about is covalent. It kind of says it right here. Covalent bonds are cooperating bonds, meaning they share electrons. They don't give or take, kind of like we just talked about with ionic. They actually share them. They're a little bit harder to go through, so we're not going to tell you too much about it. We just want you to recognize if they're ionic or covalent. If they're ionic, they have a positive and a negative. Here, you notice that oxygen here is -2. Well, since it's combining with itself, a negative and negative, you can do that. It's called covalent. Same thing for this chlorine. Chlorine's a -1, and the other chlorine's a -1. Therefore, you can combine them. Just as a remembrance, these are your diatomic molecules. They are the same chemical, the same element, but since they don't like being alone, they combine with others of their same element. Oxygen to oxygen, chlorine to chlorine. There's some of those. But we'll get to that later on. So when we're looking at these example questions, is that ionic or covalent? So MgO, well, if you look over here, Mg's got a positive. It's a metal. So Mg cannot be any type of covalent. So this would be a no. CO2, carbon dioxide. That's a bad question. I'll get back to that. PO5. P is over here in the -3s. If we look down here, O is over here in the 2s. So -3, -2, they're both negative. That creates a covalent. So I guess this would be covalent. This will actually end up being ionic. So again, just as a brief overview for today, oxidation numbers tell you the charge. They tell you if they're positive or negative. All metals are going to be positive. All non-metals are going to be negative. These tell you whether they become ionic, whether you have a positive and a negative, or covalent, meaning you have two negatives that form in different ways.